All right, we're going to finish off this unit with more optimization problems. So it says, if a farmer digs up his potatoes on July 1st, the crop will be 1,200 kilograms, which will sell at 30 cents per kilogram. If the crop is allowed to mature further, it will increase at 60 kilograms per week. However, the price will drop by 1 cent per kilogram per week. When should the farmer dig up the crop for maximum crop returns? Well, revenue is equal to the units sold multiplied by the cost per unit. Now, what's happening here is it's going to increase by 60 kilograms every week, and it's going to decrease by 1 cent every week, which means that I'm going to let X be the number of weeks after July 1st. This is going to give me a revenue of 360 plus 6x minus 0.6x squared. When I derive this, r prime of x is going to give me 6 minus 1.2x. When I do the critical numbers, then 0 is equal to 6 minus 1.2x. So 1.2x is equal to 6, so x is equal to 5. That's my only critical number. So I could have 0 weeks, I could have 5 weeks, and when I sub in values like 1 or 6 weeks into here, and I take r prime of x, that's going to give me a positive and then a negative, which means that r of x is going to increase and then decrease, and there's my maximum, where x is equal to 5. Therefore, the farmer should dig up the crops five weeks after July 1st. For example 2, it says, the same farmer from example 1, enjoying calculus far too much, decides to build 3 separate and adjacent rectangular pens for his beloved cattle. Each pen has an area of 600 meters squared, as shown in the diagram below. What dimensions should he use for each individual pen if he wishes to use a minimum length of fencing? So what do we know here? We know that he's doing each pen one by one, which means that each pen is going to have 2 lengths and 2 widths attached to it. But because 2 of the sides here are attached to each other for different pens, for the individual pens and the fencing, where if I say that L is the length of individual pens. W is the width of individual pens. And F is the amount of fencing used, or length of fencing used. Then none of these can be negative, which means that L, W, and F all have to be greater than 0. So the amount of fencing, trying to make it a minimum that they're using, is going to be 6 lengths and 4 widths. If each pen is 600 meters squared, then the area, which is length times width, is going to give me a length of 600 divided by the width, which means that the amount of fencing used is 6 times 600 over W plus 4W, or the amount of fencing is going to be 3,600 times W to the negative 1 plus 4W. When I derive this, F prime of W is going to equal negative 3,600 W to the negative 2 plus 4. Or I'm going to have negative 3,600 over W squared plus 4. I'm going to multiply the top and bottom by W squared. So F prime of W is going to equal 4W squared minus 3,600 over W squared. And in fact, I can simplify this and factor it down, and I'm going to get 4, and the difference squares, W squared minus 900, or W plus 30, W minus 30 over W squared. When I'm doing my critical numbers, then I'm going to pull from the numerator, and if I have W plus 30 is equal to 0, then W would equal negative 30. We know that doesn't make sense. We'd have W minus 30 equals 0, so W would equal 30, and that can make sense. And in the denominator, W squared is equal to 0, which means that W would equal 0, and that also does not make sense given our domain or our restrictions. So the only answer that makes sense is 30. So what are we going to state? We're going to say that we have 0, we have 30, so we can pick 1 and 35. And my F prime at W is going to be negative and then positive, which means that my F of W is going to be decreasing and then increasing and there is my min. So if my min is when W is equal to 30 meters, then that is when my length is going to equal 600 divided by W, which is going to be 20 meters. And we can state the dimensions of each individual pen should be 20 meters by 30 meters to minimize fencing.